In Chapter 9, Section 1, we're going to focus on linear and nonlinear systems of equations. So we're solving systems here. When you're solving systems, there's different methods to choose. One method that you learned was solving using substitution. There's certain scenarios, you can use it at any time, but obviously there's certain scenarios where solving with substitution is simpler. Other methods you've learned is solving by elimination, which again, there's certain criteria when that's the easier method. And lastly, solving by graphing. And solving by graphing is never going to be the easier one, okay? But either way, when you're solving by substitution, you're going to solve either equation. You're going to have two equations, and you're going to solve either one for one variable. And then again, I'll walk you through the process. I don't need to read these to you. So solving a system using substitution. So if you look at your systems, it's kind of important to know what kind of equations you're dealing with. This first one is linear because notice the x and the y are both to the first power, and this one's also linear. So this means you have two lines and you're looking for the solution. So just to give you a visual, right, if we were solving this by graphing, if we have, our original coordinate plane, and if we have line 1 here, okay, and we have line 2 here, you're going to see that at some point these two lines intersect. That intersection is the solution of the two lines or the two equations. Okay, so there's an xy coordinate at the point of intersection, and that's what we're looking for. We're looking for that xy. That's the solution to the system. So when you're looking for solutions, you're looking for intersection points. So if I take that same coordinate plane and I draw two lines that are parallel to each other, notice they're never, this is line 1, here's line 2, and notice that because they're parallel, they're never going to intersect. So this represents a situation where there's no solution. And mathematically, I'll kind of give you an idea if one of these examples are a no solution, what that might look like when you have it in equation form, okay? And then the third scenario that you'll have here, again, is you'll have, your line 1 here. And then I'm going to do this in another color. Let me do it like in yellow. And you're going to have another line that falls right on top of that line. And so if you notice there, every single point on the one line is on the other. And so this is an infinitely many solutions, or we might call it as all real numbers, okay? But basically it means that every solution for one is a solution for the other because they're basically the same line. So those are the three types of solutions you can get here. So now let's work on solving these linear equations. So if you notice, you have an x plus y equals 4, and x minus y equals 2. Well, notice you have two variables, and to solve an equation with two variables, you need to have two equations to be able to do that. If you have three variables, you're going to need three equations to be able to solve it, okay? So we have two equations. We're going to basically set one equal to one variable. We're going to pick. So for example, I might start with this top equation, and I may say, well, x equals 4 minus y. So I'm solving for x in this first equation. So I'm going to go to the bottom equation, and I'm going to, instead of x there, I'm going to put 4 minus y in this place of x. So 4 minus y equals 2. So that's 4 minus 2y equals 2. Subtract 4 from both sides. Minus 2y equals minus 2. And y equals 1. So guess what? I have one value of my ordered pair. Now that I know that x is 1, I'll go back to that first one. X plus y equals 4. X plus 1 equals 4. And that means x equals 3. So my solution, these two lines, these two linear functions will intersect at the xy coordinate of 3, 1. So it's going to look something like this, and this point is going to be 3, 1. Now, could I have solved for something else? Absolutely. So what I could have done there, let me kind of erase these out, okay? I already know 3, 1 is a solution, but I could have come to this bottom one, and I could have solved for x, and I could have said x equals 2 plus y, right? And then I could have put that in here. So I would have had 2 plus y equals 4. 2 plus 2y equals 4, 2y equals 2, and y equals 1. And I would have had the same thing. I could have solved for x, right? I could have done this bottom one and said negative y equals 2 minus x, so y equals negative 2 plus x. And I could have gone to the first one and I could have done x plus negative 2 plus x equals 4. That's 2x minus 2 equals 4. 2x equals 6, and x is 3. And again, look, I would have gotten that. I would have plugged it in and gotten y. So again, there's many ways to do it. There's no right or wrong. You just have to set up the equation to solve for one variable and then plug it into the other one. So again, when I come over to here, I'm going to do substitution again. And I'll probably work with my top equation. I'm going to do x minus y equals 0. So x equals positive y. So now I'll come over to the bottom equation, 5x minus 3y equals 6, and I'll plug y in for x. So instead of 5x, it's 5y minus 3y equals 6. I'm going to get 2y equals 6 and y equals 3. So I have my first answer. So I know the solution is an ordered pair. Y is 3. Then I can go to that first equation. And the first equation is x minus y equals 0. X minus 3 equals 0. So x is 3. So I've got x is 3, y is 3. And if you want to check it, you can. 3 minus 3 equals 0. Check, that works. And 5 times 3 minus 3 times 3 equals 6. 15 minus 9 is 6. Check. So you can always check your answers by plugging your x and y combination in. So my solution, again, here is that. So I got 3, 3, and I have 3, 1 here. Now, sometimes they're going to give you word problems. And again, when you have two coordinates or two variables, you're going to need to use two equations to solve. So it starts out and it says a total of $12,000 is invested in two funds. Let's call those funds Fund X and Fund Y. So I know that the money in X plus the money in Y equals 12,000. That's my first equation. Then I go to my second sentence and it says, or second part, basically the two funds pay 5% and 3% simple interest. And the total annual interest earned is 500. So I could do something like this. 0.05% of X plus 0.03%, like 3%, right? 0.03 of Y is going to equal 500. And so what I did was, this is the amount in each fund and this is the interest earned from each fund. But what I was able to do is get an equation going here, or two equations with two variables. So now I can solve. So I'm going to take that first equation, x plus y equals 12,000, and I'm going to solve for x. So x equals 12,000 minus y. And I'm going to go to this equation here, and for x, I'm going to put 12,000 minus y. Okay? And then plus 0.03y equals 500. I'm going to distribute the 0.05, and I'm going to get 600 when I distribute that. I'm going to get 600 minus 0.05y plus 0.03y equals 500. I'm going to combine those y's. I get minus 0.02y equals 500. Kind of keep going here. So 600 minus 0.02y equals 500. I'll subtract 600 from both sides, and that's going to give me minus 100. And if I divide both sides by negative 0.02, I'm going to get that y equals 5,000. So the amount in account Y is 5,000, which means the amount in X is 7,000. So I've got $7,000 in X, and X, I made it the 0.05% at 5% interest, and the 5,000 is at the 3%. Okay, and that's how we got it. So there's our answer. So, and like this, there's several types of word problems that you're going to get where you can create these two variable equations. So again here, a total of $25,000 is invested in two funds. So again, I've got fund X and fund Y together add up to $25,000. When it comes to the interest, one is paying 6.5, one's paying 8.5, and the annual interest is $2,000. So I'll make 6.5 of X plus 8.5. Now this is percent, right? Percent of Y equals 2,000. And I'm going to do that obviously as decimals. So 0.065X plus 0.085Y equals 2,000. Okay, so we don't really like percents like that. Okay, and so again, now I'm going to solve. In the last one, I solved for X, so I could, in this one, solve for Y. It doesn't really matter which one you solve for. I'll kind of show you Y just so you can see how we did it. So we'll do Y equals 25,000 minus X. So I'll come down to this equation here. I'll do it here. So 0.065X plus 0.085 times Y, but Y is now 25,000 minus X, and I'll make it equal to $2,000. I'm going to have to distribute the 0.085, and I'm going to get 2,125, and then I'm going to get minus 0.085X equals 2,000. I'm going to combine these like terms, which is going to leave me with 0.02X plus 2,125 equals 2,000. I'm going to subtract 2,125 from both sides. So 0.02X is equal to minus 125. And I'm going to divide by 0.02. And I'm going to get that X equals. And I should note that this ended up being a negative 0.02 dividing by negative, right? Negative like that. So I get X equals 6250. So now I know that account X is $6,250 at a 6.5% rate. And I know that Y is going to be 25,000 minus the 6,250, which is not what I just got. Let me see. Let me try that one more time. 25,000 minus 6,250. And I get $18,750 at the 8.5% interest. That was my X, and this is my Y. Okay, and so again, you just solved that problem. Now, what happens when you get nonlinear systems? And so this is where we're going to have a lot of examples of all different ones, okay? So anytime you have systems that have exponents, basically other than 1, okay? So we know when the exponents are 1, they're linear, right? So anything where the exponent is other than 1 is a nonlinear system. And so we've done a lot of nonlinear systems. I mean, we've done, basically it means systems with equations that aren't lines. And so one of them could be a line, but one could be a quadratic, which looks like a parabola that opens up or down. So that's going to be where your X is squared and your Y is to the first power, right? And so a quadratic, if I have a quadratic and let's say I have a line, that might be something like this where there's no solution because the line doesn't touch the quadratic. It could be something like this where it only touches at the vertices, so it may have one solution or at one location, right? Or you might even have a quadratic that looks like this and a line that goes through it and it intersects at 2, so you have 2 solutions. So when you have like a quadratic equation and a linear equation, you may have 0, 1, or 2 solutions. We might give you, let's say we may give you a circle and a parabola. And so, that could be kind of interesting. We could give you a circle and we could give you a parabola that goes through it like that. We could give you a parabola that maybe, again, you have a circle and a parabola, and maybe there's 4 points they have in common. Or maybe we could do a circle and a hyperbola. I don't know. Maybe we give you that and you have, something that goes like this and something that goes like this. And so, there's multiple solutions. So again, depending on the equations we give you, There could be no solution, one solution, two solutions, maybe four solutions. It's really going to depend on the equations that you're given. So it's really important, I think, when we give you these equations to kind of identify what equations you have, and sort of in your head think about how many possible solutions could you have. So when we come to this page, and we're going to basically do this page 5, 6, and 7, and then I think we'll leave 8 and the other ones for another day. Okay, so this will all be part of part 1. And mainly that's because these are going to be, linear and quadratic, which is something that you did in Algebra 1. Notice this is a linear equation and this is a quadratic. Notice only the x is squared. This is a linear equation, and again, this is a quadratic. And then here we start to get a little more complicated because this one's linear, but notice this one has an x and a y squared, and we'll talk about that when we get to it in the next part, okay? That'll be a separate video. So we're going to stop this video at 8. So we're going to just, we'll go to here. Stop here for part 1, okay? And we'll focus on these 3 today, and the rest in a second video. So what we're going to do for the first one is, again, you have a quadratic equation and you have a linear equation. And what we're going to do is we're going to try to take the linear one and solve for a variable. So I could start out, for example, by doing minus y equals -1 minus 2x. And then if I multiply everything by -1, I get y equals 1 plus 2x. So I'll take this and I'll plug it into the first equation for y, the quadratic. So I start 3x squared plus 4x minus y, and y is now 1 plus 2x equals 7. So 3x squared plus 4x minus 1 minus 2x equals 7. Combine my like terms. This is going to be plus 2x minus 1 equals 7. And since it's a quadratic, I know I have to set it equal to 0 and solve by factoring. So now I just have to factor this. And again, we all factor different ways. I know y'all learned in different ways in Algebra 1. The way I do it, again, is I do my product is minus 24. My sum is positive 2. So I know that's plus 6 minus 4. And it's going to be 3x squared plus 6x minus 4x minus 8 equals 0. Group the first two, group the second two. 3x, x plus 2, minus 4, x plus 2. So my factors are 3x minus 4 and x plus 2 equals 0. So I know 3x minus 4 equals 0, so 3x equals 4, x equals 4/3. And then the other one is x plus 2 equals 0, so x equals -2. So now I have my two x's, right? So I've got 4/3 for one x. I need to find the y for that. And I've got -2 for the other x, and I have to find the y for that one. Now, you're going to have potentially multiple solutions. When you have an x squared, you may get an extraneous and stuff like that. One of the ways to avoid getting an extraneous answer is by taking these answers, and when you plug it into the linear equation to check it, okay? So to check it, I'm going to do 2 times 4/3 minus y equals -1. So I'll get 8/3 minus y equals -1. Negative y equals -1 minus 8/3. So that's going to be, we could make this -3/3. So it's going to be -11/3. So y equals 11/3. So there's the second part of that one. And then the other one is a -2. So again, I go 2 times -2 minus y equals -1. Minus 4 minus y equals -1. Minus y equals +3, or y equals -3. And so here are my two ordered pairs. So there are 2 points of intersection between that line and that quadratic equation or that parabola. Those are my solutions. All right, so then I go to the next one. So again, I have a linear and a quadratic, And I'm going to focus again on solving for the linear. So I'm going to do this one. I'm going to go y equals 2x plus 5. And so I'm going to sub this in for y here. And so I'm going to get, when I write this out, I'm going to get x squared minus 2x plus 5 plus 3x equals 1. That's x squared minus 2x minus 5 plus 3x equals 1. X squared plus x minus 5 equals 1. And x squared plus x minus 6 equals 0. And so again, I have to think about that. Product of negative 6, sum of 1. So I'm like, oh, that's plus 3 minus 2. So this is an x plus 3 and an x minus 2 when I factor it. So x is negative 3 and x is positive 2. So I know I'm going to get two solutions here. One is going to have an x of negative 3 and one is going to have an x of 2. Now, to figure out which one, I could plug it back into the linear one. That's always the easier one. It also avoids extraneous. Or I could even plug it into the one that I kind of manipulated because, again, I'm looking for y. So that actually might be a little bit easier, right? So I could do y equals 2 times negative 3 plus 5, which equals negative 6 plus 5, which equals negative 1. So when x is negative 3, y is negative 1. And I do it again. And when x is 2, I know that y is 9. And so 2, 9 are my ordered pairs. And so that's how I do that. Last but not least, I come to this last one. And again, I can use substitution. I'm going to show you tomorrow, when I go to the next part, another way of solving these is through elimination. And maybe I'll show you how to do that. But let me just focus on substitution for right now, since I've been doing that. Again, I know that I can start here with this top one, and I can make it y equals x plus 4. And then I go to the second one, x squared plus y, which is x plus 4, equals 3. So I get x squared plus x plus 4 is 3, or x squared plus x plus 1 equals 0. And this is not factorable. And so I have to use the quadratic equation here to get to my solution. So A is 1, B is 1, and C is 1. So I've got x equals the opposite of b plus or minus b squared minus 4ac, which is just 4, all over 2a, which is 2. And then I get here minus 1 plus or minus square root of negative 3 over 2. So x equals negative 1 plus or minus I radical 3 over 2. And this means no real solution. This is an imaginary solution. When there's no real solution, it means that your graph does not intersect on the coordinate plane. So there's no point of intersection. However, if we ask you for all solutions, regardless of whether they intersect or not, then you do have to come up with this and come up with the ordered pair if we ask you to. But bottom line is this should be enough for imaginary. If we ask you to solve one by elimination, let me just kind of do one. Let me go do this top one, number 6, using potentially elimination, just to kind of remind you on elimination. Again, you start out here, plus y equals 5, and you have x squared minus y plus 3x equals 1. And sometimes, if you notice, if you add yours together, sometimes the variables are opposites and they eliminate each other because they're opposites. Sometimes it happens naturally. Sometimes it happens because you multiplied everything by something to make that happen. In this case, it just happened when you added it. So I know x squared doesn't have another like term. Minus 2x doesn't either. Or that's not true. I actually have minus 2x up top plus 3x on the bottom. So that's x squared plus x, right? And then over here I have 6. And then now I'm ready to solve. Notice there's no y's. So x squared plus x minus 6 equals 0. And notice that that's the same step we were here, but we did it in a little bit less steps. So again, you can add your columns. You probably should be a little bit better than I was about organizing it. you know, your like terms. In other words, maybe put the x squared up top, the plus 3x here, then maybe the minus y equals 1, and then here there's a minus 2x, a plus y, and an equals 5. That way things are consistent, right? So you've got here x squared plus x, these eliminate, equals 6. And then again, you can go from there. But elimination is very handy. Let me show you another example. Let's say I was to come to number 7 and use elimination. Again, it's just a different way. You learned elimination back when you did this with linear equations in Algebra 1. So again, let me just focus a little bit on the equations. I've got x squared, let me do the bottom one, plus y equals 3. And the top one is minus x, which I don't see here, plus y equals 4. So right now, if I added my columns, nothing would eliminate because there's no opposites. But if I did multiply, let's say, the bottom by -1, all of a sudden, I'm going to have positive x minus y equals -4. Cancel that out. And then I'm going to get x squared plus x. My plus y and my minus y cancel, and I get -1. So x squared plus x plus 1 equals 0. And again, I'm right here. So elimination took me to that step. So whether I use substitution or elimination, at some point I'm going to get to the same thing, that the bottom that has to be factored or quadratic, but it's two different ways of getting there. So again, I hope this refreshed your memory a little bit on elimination. Again, tomorrow we'll focus more on these, number 8, and then the next slide.